Far below the reach of sunlight, in a realm where pressure would crush unprotected life and silence reigns uninterrupted, a strange and gentle figure drifts through the water column. It does not crawl along the seafloor like other octopuses, nor does it rely on bursts of speed to escape danger. Instead, it moves with slow, deliberate grace, flapping ear-like fins that give it an almost dreamlike appearance. This is the Dumbo octopus, one of the deepest living octopus species known to science, and one of the most unusual adaptations to life in the abyss. Named for its resemblance to the animated elephant with oversized ears, the Dumbo octopus belongs to the genus Grimpoteuthis. Unlike its shallow water relatives, it inhabits depths ranging from approximately 1,000 meters to nearly 4,000 meters below the ocean's surface. At these depths, sunlight is completely absent. Temperatures hover just above freezing, food is scarce, and pressure is immense. Yet within this hostile environment, the Dumbo octopus has evolved a lifestyle defined not by aggression or speed, but by efficiency, calm, and subtle control of movement. The evolutionary journey of the Dumbo octopus reflects the gradual specialization required to survive in the deep sea. Ancestors of modern octopuses likely lived in shallower waters, where vision played a greater role and complex camouflage was essential. As some lineages ventured deeper, natural selection favored traits that conserved energy and reduced reliance on sight. Over time, the Dumbo octopus emerged as a distinct form, optimized for drifting rather than crawling, sensing rather than seeing, and enduring rather than escaping. Physically, the Dumbo octopus differs dramatically from the octopuses most people recognize. Its body is soft and gelatinous, lacking the dense muscle mass seen in coastal species. This reduced musculature is not a weakness but an adaptation, minimizing energy expenditure in an environment where every calorie matters. Its arms are connected by a web of skin, forming a rounded, umbrella-like shape that aids in slow, controlled movement. Unlike many octopuses, it lacks ink sacs, as producing ink would be useless in the pitch-black depths where visual predators are rare. The most distinctive feature of the Dumbo octopus is the pair of fins protruding from either side of its head. These fins are not decorative. They serve as the primary means of locomotion, flapping gently to propel the animal through the water. This method of movement is remarkably efficient, allowing the octopus to hover, glide, and change direction with minimal effort. When necessary, it can still use jet propulsion by expelling water through its siphon, but this is reserved for brief moments, as it consumes valuable energy. Life in the deep sea requires a different sensory toolkit. Vision, while still present, plays a reduced role. Instead, the Dumbo octopus relies heavily on tactile and chemical senses. Its arms are lined with suckers that detect subtle changes in water chemistry and vibrations. As it drifts close to the seafloor, it uses these suckers to probe the sediment, searching for prey it cannot see. This slow, methodical approach is well suited to an environment where prey encounters are rare but predictable. Feeding behavior further illustrates the Dumbo octopus's adaptation to scarcity. It primarily consumes small invertebrates such as worms, crustaceans, and mollusks that live within or on the seafloor. Rather than overpowering prey, it envelops them gently with its webbed arms, bringing them toward its mouth. Unlike many octopuses, it does not possess a strong beak capable of crushing hard shells. Instead, it swallows prey whole or relies on softer-bodied organisms, again reflecting an energy-efficient strategy. Socially, the Dumbo octopus leads a solitary existence. In the vastness of the deep sea, encounters with others of its kind are extremely rare. There are no territories to defend and no groups to join. Each individual drifts alone, following currents and subtle environmental cues. When two Dumbo octopuses do meet, interactions are brief and functional, usually related to reproduction rather than social bonding. Reproduction in the deep sea presents significant challenges, and the Dumbo octopus has evolved a flexible strategy to cope with uncertainty. Females are capable of carrying eggs at different stages of development simultaneously. This allows them to lay eggs opportunistically when conditions are favorable, rather than relying on a specific breeding season. Eggs are deposited individually onto hard surfaces such as rocks or shells on the seafloor, where they develop slowly over extended periods. This slow development is consistent with the cold temperatures and low metabolic rates characteristic of deep-sea life. The Dumbo octopus occupies a unique ecological role within its environment. As both predator and prey, it contributes to the delicate balance of the deep-sea ecosystem. By feeding on benthic invertebrates, it helps regulate populations that might otherwise grow unchecked. In turn, it may be preyed upon by larger deep-sea predators such as fish or marine mammals that venture into the depths. Each interaction, though rarely observed, forms part of a complex and largely hidden food web. Despite its remote habitat, the Dumbo octopus is not entirely isolated from human impact. Advances in deep-sea exploration have increased encounters with this species, primarily through remotely operated vehicles and deep-sea trawling operations. While these encounters have expanded scientific understanding, they also highlight the vulnerability of deep-sea ecosystems. Habitat disturbance, pollution, and climate-driven changes in ocean chemistry pose long-term threats to species that have evolved under stable conditions for millions of years. Studying the Dumbo octopus remains a challenge. Bringing specimens to the surface often results in damage due to pressure changes, making in situ observation critical. Much of what is known comes from fleeting glimpses captured by cameras descending into the abyss. Each sighting adds another piece to the puzzle, revealing behaviors and adaptations that defy assumptions about what life can endure. The Dumbo octopus stands as a powerful reminder that survival does not always favor aggression or speed. In one of the most extreme environments on Earth, it thrives through patience, efficiency, and quiet resilience. It does not dominate its surroundings. It flows with them. In the eternal darkness of the deep sea, where noise and color fade into irrelevance, the Dumbo octopus continues its slow, silent flight, a symbol of evolution's ability to shape life for even the most unforgiving worlds.